Hello, people. It's Kaswin again. So I'm here to give you another weekly breakdown and tell you what we learned this week at Web3Bridge Cohort 7. Wow, this week was really intense. We wrote a lot of smart contracts, and I'll be taking my time to explain the codes the best I can and all of that. So stick around. Let's take a ride. So on my screen, this is one of the codes, the smart contract we wrote last week, and it is a contract that keeps record of student data and all of that. So from what we are seeing here, the name is called DB, and it has public admin. So I'll take out my time to explain each of the concepts used on this contract so you understand what we did here. So first of all, you can see on my screen on line 5 we have address public admin. So this is obviously a state variable, and state variable are being stored to the blockchain. So the records are stored to the blockchain, and if you don't write a function to override them, they will never change. They will always remain like that. So over here we have a data type of struct. Now struct, it's used to hold related data together. So, and remember, we are trying to keep students data, and there's no better way to keep related data together, which is apart from using struct. So that's why we are using structure. So you see we have student name, age, and in the last variable there is an array of scores. So you can impute student scores in that array and all of that. So on line 14 we have what we call mapping in Solidity. So whenever you hear people want to track something, like they want to keep track of records on the blockchain, mapping should always come to mind, because with mapping you can use a unique identifier to track other records. So in this case we are using address to track the student struct. So each student will have a unique address, and with that we can get their related data and all of that. So on line 16 we have an array of structs. So this is, remember, struct is a user defined data type, so you can use it just like every other data type. So here we have an array of struct called students records and all of that. So which means this array can only take in the student data type, which we declared on line 7. So moving over to the constructor that is on line 18. Now constructor is a function that runs immediately your smart contract is being deployed. So, and it runs only once. So from what you're seeing here, we are setting the admin equal to msg.sender, which means once this contract is being deployed, it sets the admin to the person that deploys the contract and all of that. The reason why we did this is because we are going to be writing a function which will require that only the admin can call that function, right? So let's move on. So on line 24, we wrote a function called init record. So what the init record function basically does is it takes in some arguments like the address. So this is the function that actually does, like, if you know, on normal web 2 you create a front end and a back end where that students can register, put their records, and it registers them to the DB. So that's exactly what we are doing here. So init record takes in that address we want to use as the unique identifier, the name of the student, and the age, with an array that can take in scores. So this is basically my design pattern. There is a better way to do this, where you can just take in a uint and you can always add to the score, you can always update it. But what we did here, what I did here basically is I'm taking in an array of scores, so you can pass as many scores as possible. That's just my design, or that's my thought pattern while implementing this. So when you do that, you make it public. And remember, whenever you're using a reference type, you always specify memory and all of that. So we'll make it public so that it can be called from anywhere. And here we now did a require statement. Require statement is used to ensure a particular condition. So we are requiring that the person that is only eligible to call this function is the admin, which you already declared while deploying the contract and all of that. So if this line 25, this code on line 25 passes, then it moves to the next line, which is line 27. So on line 27, it gets the student. Okay, so you are about initializing a new variable. So first of all, you get the, remember, when you want to initialize a variable in Solidity or when you want to declare a variable in Solidity, you have to first specify the data type. So here the data type is a struct, which is the student we created, and we are saying storage. Now the struct data type is a reference data type, and whenever you're using storage inside a function, that means you want to perform a write to state condition, like you want to write to state. If I wasn't going to write to state, I'll use memory in this place, but for the fact that I'm writing to state, that's why I have to use storage here. So storage, then the name of my variable is init student. Now I will set it to the student mapping, then in brackets the unique identifier address that will be passed here. So I've already, with this now, I've already initialize my variable and setting it to the mapping. Now I can get each of the variable in the struct, and I'll assign a value to it, and the value I'm assigning is the value that is passed as an argument when calling this function. So you see, init student.name equals to name. Name is what we got from the argument when calling this function and all of that. Then yeah, so on student record, we now did a student records dot push init student and all of that. So then on line 36, we have a show student function. So it takes in an index. The show student function, basically you put in the index of the student, and it fetches the student record and all of that, and also then returns the record of all the students. So this is one of the stuff we did. So I'll be moving up to another contract we wrote, which is a staking contract. Yeah, I'll do a little bit of explanation on that as well. All right, why is this guy taking time? All right, so we are on the staking contract. Yeah, let's look at it. So this was basically an assignment given to us to work on, and it also came out in our test. So this is what we did here. So this staking contract, I think I have the, okay, let me just explain it without looking at the instructions that was given for us to write this contract. So the staking contract basically requires users can stake on this contract, and when they stake on the contract, they have to leave the money for a particular time, for some period of time, before they can withdraw the money they staked. And once you stake, it will emit an event. So event is basically used by the front, it's a login system, it's an Ethereum login system, which also aids front-end guys to use it for proper information or proper UI messaging and all of that. So what we did here, first of all, we created a mapping that tracks the balances of users that have staked. And if you see the staking function on line 11 says require that msg.value is greater than 0. So if you want to call this function, also it's a payable function, which means it receives ETH. So it receives ETH into the contract. So if you're calling this function, you need to pass in a value. If you don't pass a value, line 12 will not let you call this function. It will revert. So once you call this function, you see we are not setting the balance of the user that is calling this function to msg.value. We are incrementing, which means you can stake multiple times as much as you can. So we also have a function user balance, which takes in the address of the user. So once you put that address and call this function, it returns the balance, the amount you have staked in this function. So we have the external payable function. Now this function is The function is like a fallback function. Let's say you didn't write a logic that will receive money into this contract, and you write a receive function. Whenever someone sends money to this contract, it will receive it. But what we now did here is, when you send money into this contract, instead of the money to just come into the contract and chill, we'll use that money you sent to stake for you. That's why inside the external payable, the receive external payable, we still call the stake function and pass in the messages.sender. So, and also, you know, the stake, when you send something, already gets the value of what you're sending. And remember, the stake just takes in the address. So in this case, the sender is the address is the messages.sender. That's the person that sent money to the contract. So you use the money to stake for you. And we now have a withdraw function that helps you withdraw this money to your wallet. So what we did here, we require that the deadline is less than blocked on timestamp. So for you to call this function, the time we specify that this money has to be in the contract must have elapsed before this guy will pass. So it also checks that msg.sender is greater, the balance of the msg.sender is greater than 0. So you don't come here to withdraw money you have not staked and all of that. So we did the so once you do this, we got the balance, the amount you have on, because this function withdraws everything you stake back to you. Then we had to set your value to 0 before we transfer the money out. This is to avoid reentrancy attack, because if we were transferring this money, let me do this, guys, so you get what I'm saying. If we were transferring this money first before actually setting this guy to 0, the person, I can write a contract function that listens to deposit. So if money comes in, it will re-enter this address and take out the money to drain it dry. So that's why we did this guy here. So we had to bring this guy over here so it makes sense. So this is the change deadline function. So in case you want to change your deadline at any point in time, remember, anything you don't write in your function cannot happen once the contract is deployed and all of that. So you have to put in check the things you really need in your contract. So we have the show deadline function as well that shows you if your deadline has elapsed, so you can withdraw your money and all of that. So I don't want to keep this video longer than this. This video is supposed to be basically 5 minutes, but it has gone very fast. So I'm gonna be stopping here for now. So expect more from me next week. So I will give you a whole lot of code breakdown and all of that. And if you think there's something wrong with this code, maybe there's a bug, please make use of the comment section. We are all learning. I'm learning, you're learning, so I'm not perfect. Thank you very much. I remain Kasfini, your guy. Peace out.